Hi, today we're going to learn about intro to sequences, and then there's for this section I'm going to go over arithmetic sequences and geometric sequence. I will not go over quadratic sequence. So, the first one I'm going to go over is arithmetic sequences. So, basically, an arithmetic sequence has a common difference. So here's the formula for nth term. It's an equals first term plus difference times n minus 1. And then if you look in the right, an example of an arithmetic sequence is 3, 7, 11, 15, 19. They have a difference of 4. And if you were to graph an arithmetic sequence, it has a linear function, because if you make the number of terms on the x value and y and number on the y value, you get a linear graph. And then here's the recursive formula. An equals an minus 1 plus d. And then to find the difference, you do the second term minus first term, and that should equal your third term minus second term. Or you could do ay minus ax divided by y minus x. Okay, and then, so geometric sequences is that they have a ratio. So if you look on the right, an example would be 0.3, 0.03, 0.003, and then the ratio is 0.1. If you were to graph it, it's going to look something like an exponential graph. So here's the recursive formula for geometric, and don't put a negative here, sorry. And then here's the formula for a geometric sequence. To find the ratio, you do a2 over a1 equals a3 over a2, and then r is y minus x equals ay divided by ax. This one, you'll see why we have to use, you'll either use this formula or this one, and then because sometimes they won't give you the first term, so you have to, there are some really tricky problems, but we'll go over it. Okay, so it says find all terms of each finite sequence. So it's basically saying, here's your restriction. So it's saying n must be greater or equal to 1, or n is less than or equal to 7. So basically you got to find n is from 1 to 7. Yeah, so this one's pretty simple. So we got to find all terms. So we got to go all the way from B1 to B7 because that's our restriction. So B1 is just putting 1 in for n, right? N equals 1. So that's 1 minus 1, 0.5. That becomes 0. So this is just B1 equals 5. B2 is so it's just plugging 2 for n. It's not too hard, right? Three minus 1 is 2. I'm just going to do that in my head. Three minus 1 is, what is this, before? So yeah, 4 minus 1 is 3. So that equals 6. is 5 plus 5 minus 1 is 4. 0.5. So that equals 7. B6 is 5 plus 6 minus 1 is 5. 0.5. And then that's 7.5. And the last one is B7. Is 5 plus 7 minus 1 is 6. So that equals 8. So here's your numbers. So you have a 5, 5.5, 6, 6.5, 7, 7.5, and 8. So what can you tell me? This has a common difference of 0.5. What is a difference? What happens when you have a difference? It's arithmetic, right? Because arithmetic sequences, arithmetic has a common difference. So this is your answer, right? It doesn't ask you for the common difference. So okay, find the first 4 terms in the 10th term of each infinite sequence whose nth term is given. Just like the last one, you just gotta plug in 1, 2, 3, 4, and 10. So if you did the work, you should get -1, and then 1 plus 1 is 2. I'm just gonna do this in my head. So remember, it's when n equals 1. So 1 plus 2 is 3. So that gives us -1 over 6. Two plus 1 is 3. 2 plus 2 is 4. So that's 1/12. Three plus 1 is 4. 3 plus 2 is 5. So that gives us -120. A fourth. So it's -1 to the 4th. 4 plus 1 is 5. 4 plus 2 is 5 and 6. So a to the 4th is positive 130. Okay, and a to the 10th is, because we got to find the 10th term. Ten plus 1 is 11. 10 plus 2 is 12. Oops. So that gives us 1 over 132. So your sequences is -1, 6, 1/12, -120. I mean -1 over 20. 1 positive 30. And then the 10th term is 1 over 132. Okay, so if you, as you look at this, there is no common difference or ratios, right? If you took, so this is A1, A2, A3. If you did A2 minus A1 equals A3 minus A2. I did the work and they don't equal the same. The same thing with ratio. If A2 divided by A1 does not equal A3 over A2. So so it's neither a geometric or arithmetic. It could be a quadratic sequence. So, but this is your final answer. Okay, write a formula for the nth term of each infinite sequence. Do not use a recursion formula. So, we got to figure out one thing. We got to find if it's a geometric or arithmetic. So I'm going to check if it's a geometric. So geometric must have a common ratio, right? Common ratio. So we'll call this A1, A2, A3. So the ratio should be A2 divided by A1 should equal A3. Where was I? A3 over A2. So this has to be true. So R2 is 1/2 divided by A1, which is 1. So that's 1/2. Now, where's A3? A3 is 1/4 divided by A2, which is 1/2. Compound fraction, so let's multiply everything by 4. So that's 1. 4 times 1/2 is 2. So they equal the same, so they must be, it has a common ratio of 1/2. So we know it's geometric. So geometric sequence. Okay, now we have to use the if we know the geometric sequence, we can use, it says do not use a recursion formula, so let's go back to our formulas. So we should use this one, right? We're going to use this formula, an equals first term times ratio, raise it to n minus 1. So our an, our first term is 1. Our ratio is 1/2. And then raise everything to the n1. If you were to simplify it, you would get an would be 1 over 2n minus 1. And this formula does work, because if you put n equals 1, 1 minus 1 is 0, 2 to the 0 is 1, so it's 1/2. If you do 2, it'd be 2 minus 1 would be 1, so that's be 1/2, and 3 minus 1 is 2, 2 to the 1 over 2/3, 3 minus 1 is 2, and 1 over 2 squared is 1/4. So this formula works. Find the first 4 terms and 8th terms of each infinite sequence given by the recursion formula. Find the first 4 terms and 8th terms. Find the first 4 terms and 8th terms by a recursion formula. So we know that so we gotta find. So we know the first term is a1 to the negative 15. let's find the second term. So we got to use this formula. So we say n is 2, so 2 minus 1 is 1. Here, 2 minus 1 is 1 plus 7. So 2 minus 1 is 1, so it'd be a1 plus 7. So the first term, we know the first term is negative 15 plus 7, so that should give us negative 8. A3 is 3 minus 1, so 3 minus 1 is 2, so a subscript 2 plus 7. So we know a2 is negative 8, so negative 8 plus 7, so that gives us negative 1. A fourth is 4 minus 1 is 3, so it's a3 plus 7. We know the third term is negative 1 plus 7, so that's 6. And then we need to find the 8th term. Okay, so this one's a little bit tricky. We cannot find the 8th term because if we use 8 as the n, so it'd be so it'd be a minus 1, 8 minus 1, so that plus 7. So that's a to the 7th plus 7. We don't know what the 7th term. So what we're going to do is let's check if it has a common difference. So so we know our first term is negative 15, second term is negative 8, third term is negative 1. So this is a1, a2, a3. So let's find the common difference. So the difference says a2 minus a1. So here's a2 minus a1, so minus negative 15. So that's 7. Now let's see if it's a3 minus a2. So here's a3, so negative 1 minus a negative 8. That equals positive 7. So they're both true, so let me write. So a2 minus a1, and then a3 minus a2, they both equal to each other, so we know if they have a common difference, then we know it's this arithmetic, and the difference is 7. So it says if we know that, we can also use, we can use the nth term for the arithmetic sequence. So the nth term for the arithmetic sequence is an equals a1 plus dn minus 1, right? We got to find the 8th term. So let's find the 8th term. So we'll use n equals 8. N equals 8. So it would be a to the 8th equals first term, which we know, which is right here, negative 15, plus difference, which is 7, positive 7. And then our n is 8, so 8 minus 1 is 7. So that's 49 minus 15, and then that should give us 34. Positive 34. So our answer should be negative 15, negative 8, negative 1, 6, and then the 8th term is 34. This is a1, a2, a3, a4, and then a8. So that is your final answer. Yeah, see, it's not that hard. You just got to figure out, is it geometric or arithmetic? And let's keep on going. Determine whether each sequence could be arithmetic or could be an arithmetic sequence. So remember arithmetic sequence, they must have a common difference. So A2 minus A1 should equal A3 minus A2. So this is A1, A2, and A3. So A2 is pi halves minus pi fourths, and that should give us, get a common, times this by 2, so that's 2 pi. 2 pi minus pi is pi fourths. Okay, now let's do A3 minus A2. So A3 is 3 pi fourths minus pi halves times this by 2. So that's 2 pi. 3 pi minus 2 pi is pi fourth. They're both the same, so they do have a common difference. So yes, it's arithmetic sequence and a common difference of pi fourths. Write a formula for the nth term of each arithmetic sequence. Do not use recursion form. So we know that we know it's arithmetic, and then so we got to find the common difference. So this is A1, A2. So difference is A2 minus A1, which is 35, minus 20, which is 15. Now, what I'm not going to do is I'm not going to do A2 minus A1 equals A3 minus A2 because we already know it's arithmetic sequence because they said so. So we just got to figure out the difference is 15. Some people can really see it. Some people can say, oh, that's the difference of 15, but I can't. So the difference is 15. So we use the nth formula for arithmetic. So it's going to be an equals a1 plus difference and n minus 1. So an is, we know the first term is 20. We know the difference is 15. So if you distribute that, 15 would be 15n minus 15 plus 20. So our final answer should be 15n plus 5. Find the common difference in the sequence in the first term. Find the common difference of the sequence in which the first term is 12 and the 21st term is 96. So our first term is 12 and our 21st, we got to find the difference. Okay, so first we got to ask is, I'm going to determine if it's arithmetic and if it has a common difference. So I'm going to use the nth term of an arithmetic sequence. So it's an equals a1 plus dn minus 1. So we know quite a few things. We know that the first term is 12. Okay, and then let's use, for the n number, let's plug in 21. So let's do n equals 21. So let's do a to the 21. That's a subscript. first term plus, our goal is to find the difference, right? So difference, and then 21 minus 1. So hold on, so we know the 21st term is right here, which is 96. We know our first term is 12, right? A1 is 12, plus difference, and then 21 minus 1 is 20. Subtract 12 from both sides. 96 minus 12 is positive 84, equals, that would be 20d. Divide both sides by 20. So our difference is 4.2. Yeah, so it's just using clues and using what we know. It says find the common difference, so we know that the difference is arithmetic, so we can use the nth formula for arithmetic sequence. We know the 21st term, and we know the first term. So if we use this formula, we could put the first term is 96. Our 21st term is 96. First term is 12. We know n is 21, right? N is 21, so 21 minus 1 is 20. Subtract that, do the work, and then solve for d, and d equals 4.2. Find the 8th term of the sequence that has the first term of -3 and a common difference of 5. So we gotta find the 8th term. And then so we don't know what the 8th term. We know the first term is -3. That should be negative right here. -3, and we know the common difference is 5. So we know that if it has a common difference, we know it's arithmetic, right? So we'll use the nth formula for the arithmetic sequence. So that's an equals first term plus d times n minus 1, right? So we know, let's use n equals 8. So find the 8, yeah, because we want to find the 8th term. So a8, we know the first term is -3. We know the difference is 5. And then 8 minus 1 is 7, right? Because we're using n equals 8. So a8, the 8th term is -3 plus 7 times 5 is 35. a8 equals 35 minus 3 is positive 32. So that's how you find the 8th term. You just use clues, use what you know, and then use the formulas that you know. Find a formula for the a_nth given that the 3rd term is 10 and the 7th and the 7th term is 20. So find a formula. So find a formula for given that a third is 10 and a 7th. Hold on, let me check. Okay, so this one is really kind of tricky. Okay, so what I'm going to do is find a formula. This one's kind of tricky. So they don't give us the first term. They give us the 3rd term, and then they give us the 7th term. So let's go back to our formulas. First, I'm going to check if it has a common difference. But the thing is, I'm not going to use this formula, right? Because I don't know the 2nd term or the 1st term. So I'm going to use this formula. D is y. that weird one. So I'm going to use, this formula. AY minus AX divided by Y minus X. So what I'm going to do is, we'll say, okay, so basically our Y is the subscript of 7. So 7 is A7, so the Y is 7. Our X is just the subscript of A, so that would be X equals 3. And then AY is the number, so we're A7, so that should be 20. And our AX is, where is it? We got, it should be 10, right? So let's put that in our formula. So AY is 20 minus 10 divided by 7 minus 3. 20 minus 10 is 10. 7 minus 3 is 4. 10 divided by 4 is about is exactly 2.5. Okay, so what I'm going to do is what we need to know is we need to find the first term, and then we got to find the second term. So how do we do that? We're going to use the nth formula of a arithmetic. Right? Because arithmetic has a common difference. Yeah, it has a common difference. So an equals first term plus difference n minus 1. So we're going to use what we know. So we're going to use, we'll use n equals 7, or the seventh term, so a7. Because our goal is to find the first term, so a1. And we know our difference, which is 2.5. So if n equals 7, that would be 7 minus 1 is 6, right? I just plug it in for 7. That's how I got 6. So we know the seventh term is 20. We don't know the first term, that's our goal. Plus 2.5 times by 6 is 15. Subtract 15 from both sides. So that's 5 equals first term. So our first term is 5. So the reason why I got to find A1 and A2 is because I got to figure out if it really is an arithmetic. Remember arithmetic is A2 minus A1 equals A3 minus A2. That's why I got to find A1 and A2. So our next step is to find A2, which is really simple. So A2 is, we know the first term, A2, I'm using this formula, so A2 is equal to first term, which is 5, because we just solved it, plus difference, we know the difference is 2.5. And then 2 minus 1 is 1. Let's see, maybe I think I want to, so we said that, how I got that, so n equals 2, so I'm using this formula, so it'd be n2 plus a1 plus difference, which is 2.5, and then 2 minus 1. That's how I got this formula. So a2 is 5 plus 2.5 minus 1. 2.5, that's 2.5, so a2 is 7.5. Now I gotta check if it's arithmetic, remember? So difference is, so we know the first term is 5, second term is 7.5, and our third term is 10, right? From here, A1, A2, A3. I'm doing this step to figure out if it really is an arithmetic. So A2 minus A1, so 7.5 minus 5, which is 2.5, and then A3 minus A2, which is 10 minus 7.5, which is still 2.5. So they're the same, so we know it's arithmetic with a difference of 2.5. So now we can put it in, our goal, now we can put it in the formula. So AN equals this formula. First term is 5 plus difference, which is 2.5, and then n minus 1. If you were to simplify it, you would get, if you were to FOIL it and do all the work, you would get an AN equals 2.5n plus 2.5. This is your final answer. So that, yeah, this one was probably the hardest one of them all. And then let's do a final one, yay. Write a recursion formula for each sequence. So, sorry, I'm looking at my notes. So we have 3, 1, so this is A1, A2, A3. Okay, so let's figure out if it has a difference or arithmetic sequence. So it's A2 minus A1, so it's 12 minus 3, which is 9. And then A3 minus A2, which is 21 minus 12, which is 9. So yes, they have common difference of 9. So it's definitely arithmetic. So it's arithmetic. So write a recursion formula. So we know the formula for the recursive of an arithmetic sequence is AN equals AN minus 1 plus D, right? We got that formula from this one, arithmetic, and it's recursive, this one. Okay, so let's just fill in the blanks. So AN equals AN minus 1, and we know the difference is 9, so it's just plus 9. That's our final answer, and that wraps it up for this section.